of idempotent operation, and I have already explained before that it is an operation in which the transaction, if repeated, doesn't have monetary effect on the database or the transaction. So you can see that if we have an operation in which we say increment x by 1000, if the x is lost and then we, as a precaution, then we send again the request, and it is possible that it will be incremented twice. An example of not idempotent operation. So what is an example of idempotent operation? That you check the availability of a product, okay? Whether you check it by 10 times or 100 times, it will not affect the monetary value of that transaction, okay? That's perfect. The delivery mechanism, we can intuitively draw some conclusions that if at most once the delivery means that if the message handled to the mechanism, that message is delivered 0 or 1 time, okay, at most 1 is casual. In casual term we can say that message may be lost, okay. If the egg is once, so message will be delivered. If it is not, which is 0 time, so in that case it is possible that the message will be is lost, okay. So at least one, so we can have more than once x, so it means that it is possibility that there will be duplicate messages, okay, because sending messages more than once, okay. So although we will surely get the message, but it is possible that there are multiple messages on the receiving end, so exactly once. So in this delivery mechanism means that each message handled to the mechanism exactly once delivery is made to the recipient. The message can neither be lost or not duplicate, okay, in the third case. So there are three scenarios for delivery mechanism as we have discussed. So let's focus on centralized architectures in terms of user interface, okay. Every application that our data software engineer designs, it has three basic components or parts, okay. So which one of these are? First is user interface, and then we have processing level, and then we have data, okay, or database, okay. So any application that we will consider will have three basic components as mentioned. So let's further explain this. In client server systems, user interface GUI, and it interact with the it has a interact with the user who want to access the system. Processing level is the data is processed by the application. This is the core functionality, okay. And data level is database or file system, okay. So there are two types of data. One is database and other one is file system, okay. Data usually is persistent. It means that it exists there even though you access it or not. So we have two type of files, data, file or database systems, okay. So these are the three examples. If I ask you that give me two examples of this layered architecture of client server systems. So these are the three. First is web search engine, okay. So you have an interface in which you type keywords, and then there is a processing level in which the data queries are processed using database on database. Is a database of a web page, okay. As we have databases of or in terms of warehouse for YouTube, Facebook, and others, and the same is stands for stock broker decision support system, okay. And it has interface, then processing and data level, okay. And desktop, for example, Office suites, it has interface, this document in which we can type data, okay. processing, word processing, database queries, spreadsheets are used for processing purposes. So data is in this case is file system or database system. Well, so application layer example in terms of structure or components is defined here. As we have mentioned many times before, that an application or any software has three components, okay, three parts. User interface, it comprises of this block, and then we have processing level, in which we have this three component, in which query generator, HTML generator, and render. In web scraping, we have seen that all the web pages generally consist of HTML code, okay, and then we have data level. Every website or an application, it has a database. Okay? How about the system architectures in terms of layers or tiers? Okay. So what is the difference between the layers and tiers? Okay. Layers are generally related to software. Okay. Software components, and tier are generally related with the hardware components. Although they are typically interchangeably used, but you must keep in mind the difference. Layers are related to software and tiers are related to hardware components. Okay, so there can be two-tier or three-tier mechanisms. Okay, so let's proceed. Uh, First, let me come over here. Okay, so these are the A, B, C, D, E. 5 examples of two-tier architecture. Okay, so here client only comprise of user interface and all the other functionalities like the processing and database and application. They are on the server. Okay, and you can see over here that the functionality is interchanging towards E. It means that this is in here the client has a user interface, application, and database, and its own database. Okay, but at server, it has just a big database which is used to interact with all the user applications. Okay, so this is an example of fat client. Okay, because here most of the processing is being done, okay, on the okay, and here it is an example of an example of fat client, and this is an example of thin client, because the least processing is being done over here. Okay, having said that, and after understanding this, let's go back to the previous slide, that server provides processing and data management. Client provides simple graphical display. Okay, so this is called thin client. Perceived performance loss at client. Okay, so it is possible that in this case of scenario in thin client, performance is lost because the client don't have powerful machines. So it can be expected that it will cause delays and expected time to have a result. Earlier to manage, this is easier to manage because the client has a least functionality. Another extreme, okay, which is the referred as E. Okay, so in this case we have a fat client. Pros are reduce the workload at the server, okay, because most of the functionality is being found at the client side. This is more scalable. Cons are harder to manage by the system admin, because for a fat client you have to have some system administrator who has to manage the functionality. Okay? So if this is I think not very clear that what are the thin client and the fat client, and in terms of also architecture. So how about the three-tier architecture? So in three-tier architecture, we have a user interface on one layer, application server on the second layer, and the third layer consists of database server. So in terms of architecture, we have a vertical distribution of resources and we have horizontal distribution of resources. Okay. So in vertical distribution, typically like multi-tier architecture. So these are the examples of two-tier and three-tier architectures are the examples of vertical distribution. So how about the horizontal distribution? P2P systems are horizontal distribution. Okay. So how about vertical fragmentation? So this is in which placing different component on different machines. Okay, so there is not a single component, but multiple components they are placed on multiple machines. Okay. So what is overlay network? Okay? Overlay network is a network which is working on top of another network. For example, IP networks. You can see that in IP networks we have IP addresses assigned to each of the machines, but on hardware level they are also comprised of other addresses which are hardware addresses. Okay, so the IP addresses are mapped on top of the hardware addresses, which is MAC address. Okay, so this kind of network are the example of overlay network. Okay, again, overlay network is a network in which on top of one network there is another network. Okay, similarly, content delivery networks are also example of uh, the overlay network. Okay, in which the machine number like 1 2 3 4 5 they are also mapped with the hardware addresses, which is MAC addresses. Okay, so on top of hardware network hardware addresses there lies the content delivery network. Okay? So there are two type of overlay networks: structured and unstructured. Okay, so peer-to-peer architecture evolved how to organize processes in an overlay network. Is a computer network built on top of another network. Nodes in an overlay network can be thought of connected by virtual or logical links. So on hardware level, machines are connected with the wires. But on top of that, there is also software network or like computer network. Well, let's proceed. So client server architecture example is given over here. Okay. So structurally, connection wise, what is the difference between client server model and P2P server? So this is very clear, I think, that we have clients over connected with the server. And over here we have in P2P network, like every computer is like connected either through another computer or directly connected to another computer. Okay. So this is again an example of overlay network. So this is a physical network in which the machines are assigned physical addresses or MAC addresses, and on top of that we have IP network in which machines are assigned with IP addresses. So routing in peer-to-peer network is here. This is an example of routing in peer-to-peer network. Okay, so machine can connect to directly or through another machine. So this is like a disorganized example of a network, and this is a tier guide. Okay, so you can see that here the machines are assigned with some numbers, okay, in order to 25 numbers. So this is the peer ring. Okay, if we can see over here, this is the peer ring. Okay, the computer are connected with each other in the peer farms. Again, this is another example of P2P routing. And if you want to do some messagings, let's say from 0 to 1 and 0 to 2 and 4 and 5, we can directly do that. And the peer-to-peer routing table that if machine this want to connect to other machines, so it can be done in this way. Okay? And in this way, the routing table for peer-to-peer network is built. So how does the like routing mechanism of P2P network works? That our peer which want to join a service, it send a join request, and the peer then boot up and it send a guide request or a resource availability request response. Okay, so uh, here, like if a client want to leave a system, it send the zero send the leave request to all the concerned only, okay, in which it is connected. Uh, so in case of like find closest and then crash peer, if this is this peer is crashed, so it will respond back to the zero machine, and then it will find another machine that is closed on it. So this is an actual node in which uh, we have 0, 1, and then we have this machine which is connected with 13, 14, and 15, and this machine is connected with these associated machine with their uh, associated data keys. Okay, so this is very easy. Please read the book, then you will also have some insight into that. Okay, so if some node is failed, then we have to select a successor. Okay, so in this case we have N32 as a successor. Okay, then we have these values as a data with the key. It has key K24 and the K30. Routing in peer-to-peer network, for example, code. In this case, let's consider a scenario in which N26 want to join the system. Okay, and then N26 acquires N32 as its successor. Okay, so N26 notifies N32, and N32 acquires N26 as its predecessor. Okay, so successor and predecessor process is performed in this way. Okay, this is an example. So again, further to that, N26 copies keys. Okay, let's say K24, which was with this guy. N21 runs stabilize function and asks its successor N32 for its predecessor is which is N26. Okay, so it should be informed as well that predecessor successor has been selected. So successor should inform to the predecessor using stabilize mechanism or function. So you can see this that in this way the routing table is built. Okay, so routing in peer-to-peer network, again I will let's consider this first. Uh, First, this table is having an entry that N8. Um, this is like a finger table, like this has like in hand shape, and it has 5 fingers which are connected to the different nodes. Okay, so these nodes which are connected, they should be populated in this finger table. Okay, so first of all, so we have here N8. Okay, and then we have +1, and then we have with +1, which means that by one hop it is connected with N14. Okay, and further to that, and then we have N8 with +2. +2 means with 2 hops. So N8 with 2 hops is connected with N14. Okay, so here it is like this is here, and we have N+2, and this is also connected with this. through, for example, this and this. And keeping onward that with the 4 hops, it is connected also with the N14. And you see a successor is like N plus 2 I minus 1. Okay, so these are the hops 1, 4, and then what will be here? 8. Okay, so through 8 this is this, and through 16 this is this, and through 16 32 it is over here. Okay, so these are the keys, and 8 plus 2, 1, 2, 4, 5, 6, and so on. Okay, so this is how this figure table is populated. Please understand this, and if you don't understand, please read some examples. Okay, so I can give some other example to you to understand this process, but this will not be like very similar to this, so you can expect similar kind of example. Okay. Uh, so this is N42, and its table is like that. Okay, same plus 1, 2, 4, 4, 8, 16, and 32, and by that it is connected 48 and 51 and 1 and 40 and 14. Okay, so these are these guys. Okay, which is connected to that. Okay, peer-to-peer algorithm is called churn, in which node joins, leaves, and report the failure. Due to the churn behavior of code, high network bandwidth is consumed. Okay, why? Because it has to build large size tables. Okay, because most of the machines are either connected directly or through another machine. Okay. One possible solution is to keep pointers to original locations other than R factors of replication. Okay, if we have pointers instead of big tables, so we can have identification that which node is connected to which one. So availability and resilience. Replicate blocks at R successors. Okay, so this is a block 17, in which we have this is original and 20, and then we have replicas. Okay, replicas mean that they are like for example, if this is a server and this is another replica server and this is a backup server. Okay. Okay. Uh, so lookup setup is like that, in which we have a block 17, here we have block 17, and if this one is failed. Okay, so what we have to do that if this guy is requesting and this is failed, so how this guy will know that it is failed? So we will set do lookup search and then get successor list. So these are two successors, for example, replicas. Failed block fetch. Okay, so this should be identified as a failed, and then block the fetch. This should be blocked like a crossed. So we cannot access anymore this, and all the other neighbor will know. Uh, so why virtual nodes? We have already kind of explored that we needed backup servers, we needed virtual server and replica servers in order to have better availability. Okay, okay, so you can see that this is a client, and this is these are also 3 clients, and in this case they are acting as server, and they have 3 nodes uh, publishing the similar services. Okay, if one fails, then the other succeeds, and the predecessor also should be notified. So physical locality aware patch choice. Okay, in this, so we are almost finished with let's do that. Maybe today class will finish a little bit earlier. Okay. In this case, each node monitors RTTS to its own fingers. Okay, so okay, so you can see that each of the node, like in this case, node 48, want to have a lookup for node 47. Okay, but node 47 is here, maybe over here somewhere. Okay, not shown here. So it should be looking for its own fingers, but in this it is not available, but it's over here to somewhere. So pick smallest RTT RTT choice. So it's like a time window in which we want to know about some existing resources, and if these are available, so it should be notified within the, for example, within given time. For example, this time is 20 milliseconds, this is 50, and this is 10, and this is 100. And if, like at most at 100 milliseconds, it's not reported that it is existing or not, so it should notify that it doesn't exist in this finger table. Okay, then it should look elsewhere. So we can also have a greedy approach, that we can select the smallest time. Okay. So distance between peer and in its code. So distance, you should know that formula. Okay. So how the distance between peers and its code, its nodes is defined using the code algorithm. So distance BA is equal to B minus A plus 2 raised power n mod 2 raised power n. Okay. So try that. So we don't have any reading assignments. So unstructured peer-to-peer architecture. So in this, we rely on random algorithm for constructing an overlay network. So what is an overlay network? I have already explained. So can anyone give me an example? I have given you two examples of overlay networks. So yes, anyone? Okay. So I think next time I will take attendance by calling the people names, so that I know that if somebody is present or not. Today is like a very low presence of students. What is it is?
Sir, overlay network, I guess peer-to-peer network. Okay, I'm not sure.
Okay. So again, I have given you two examples. One example is IP network. Okay. Overlay network is a network in which on the top of some physical network there lies a software-based network, for example. So in LAN, the addresses are defined using MAC addresses, okay, physical addresses. But you can see that on network level, so there is IP network, in which the addresses are defined by IP addresses, okay. So this kind of network which lies on top of another network is called overlay network. So another example of overlay network is the content delivery network. Okay? So in content delivery network, we have we have a network which is a physical network defined by the physical MAC addresses, and on top of that we have machines, like which machine numbers, okay, 1, 2, 3, 4, or something. So this is also an example of okay. Thank you very much. At least you participated, so I appreciate. So relies on random algorithm for constructing an overlay network. Each node maintains a list of neighbors, a list constructed in a random way. Okay. A partial view, a list of neighbors. Partial view is that not all the neighbors are selected randomly. Few of the networks are selected, such as in figure cases. Okay, in which we have 5 neighbors randomly selected. Okay, not like directly connected or something. So data items are randomly placed on data nodes. Locate a data item, flood the network. Okay. So also data is also placed randomly. Okay. Not only the neighbors are randomly selected, like how many, like from K means 2, 3, 4, 5. What we desire, that, that would be the number. Okay. And then data that, for example, the like videos or contents networks, websites. So content are placed on randomly located nodes on different places. Okay, located data item floods the network. Okay, then we locate some some video, and then we want to inform all the other network or the peers that this video with this name is available on this website. Okay, so all the other neighbors will access. So topology management. So how about the topology? So there are many examples of topologies like telephone networks, like IP networks, 3G networks. They all have different kind of topologies. So topologies could be structured and unstructured. Okay. So this is structured overlay in with protocol or specific protocols for a specific overlay, links to topology and other nodes, and random peers. Okay, so protocol for again randomized. This is for specific, and this is randomized view. Okay, the rest is the same. Okay, so this is how in overlay networks topology is managed. Okay, this is network number one, this is network number two, and this is how they are also interacting with each other. So what are the super peers? So any guess? What are the super peers? We have example over here. So can you logically or intuitively draw your conclusion that what are the super peers? जी देखिए सबसे क्वेश्चन है ऑनलाइन भी और ऑफलाइन भी जी जी सर्वर
सर पीएसए ग्रुप दूसरे पीएसए ग्रुप के साथ होता
जी उन्होंने बताया कि जो सर्वर्स हैं उसकी एग्जांपल है आपने क्या बताया
है सर पीएसए ग्रुप होता है वो दूसरे पीएसए ग्रुप के साथ में पीयर टू पीयर होता है
हाँ बिल्कुल ठीक है आप बिल्कुल ऐसे कह सकते हैं जैसे एच मशीन्स है ना इनको भी कह सकते हैं और सर्वर्स और राउटर्स एच पे होते हैं तो फिर वो दे आर आल्सो कॉल्ड सुपर पीयर्स सो गुड थैंक यू फॉर योर फीडबैक so let's see सर्चिंग डेटा आइटम्स फ्लॉट द क्यूरी हम क्या करते हैं कि बजाय अपनी क्यूरी जो हमने करनी है किसी रिसोर्स को फाइंड करने के लिए डिसाइड रिसोर्स को तो सारे नेटवर्क को फ्लड करने के बजाय हम सिर्फ उन सुपर पीयर्स को करते हैं ठीक है तो वो क्या करते हैं फिर वो अपने छोटे नेटवर्क के अंदर देखते हैं इस तरह से क्या होता है फ्लडिंग कम होती है ज़्यादा हो जाती है कम हो जाती है हाँ बिल्कुल कम हो जाती है आपका नाम जी फातिमा ने कहा कि इस तरह से ना फ्लडिंग कम हो जाती है जी Okay, nodes such as those maintaining an index or acting as a broker are generally referred to as super peers. Okay, so this is a definition. Okay, if you want to ask or write, super peers hold index of information from its associated peers. Okay, associated peers they are also like in connected as in mesh fashion. Okay, these four super nodes and they can talk to each other if this resource is available because these super peers know that what are their resources located on different nodes. Why? Because super peers hold index of information from its associated peers that is selected representative of some of the peers. Client super peer relation change as clients find better super peer. Okay, so these clients they can also switch from one a super peer to another super peer. Okay. And how about the super peer network? These four guys with the black color, they are super peers. But how about super peer network? So super peer network is the network that is composed of these super peers, okay, as their nodes for. So we were before we were talking about hybrid architecture, okay, hybrid approach. This is the combination of centralized and decentralized architecture, okay. So we have here edge servers. So since we have client and servers, we have vertical like distribution, and here collaborative network. We have uh, horizontal distribution of resources. So in edge server system, servers are deployed on internet where the services are placed. For example, at the edge. ISP is residing at the edge of the internet. A hybrid, in case of collaborative, a hybrid structure are deployed on collaborative distribution networks. Okay, that is, for example, BitTorrent. Okay, so this is the structure of that kind of system. Here we have edge server system. This is we have edge server system, and this is edge server system, and this is edge server system, and it is also over here. Okay, so this is the core of that network. So this is for today, and let's call the day off.